So here we are starting with question 16, and we can see that we're dealing with electricity, so we need to have our electricity data booklet section open there. So we have two resistors made from the same material are connected in series to a battery. The length of resistor X is twice. Okay, so the length is twice that of resistor Y, and X has twice the cross-sectional area of Y. Okay, so which formula are we going to use here? We're going to use this over here, this one over here, where we're looking at the resistance of X. So the resistance of X will equal rho. Now this is the resistivity of the material. This depends on the material itself, so that's actually going to be the same for both X and Y. Let's have the length L here and the area A. Perhaps I should make this for Y. That would make it easier perhaps. So that's Y, and then for resistance of X, that's also going to be rho, but now we've got double the length, it's 2L, but we've got double the cross-sectional area, so it's 2A. So those two will cancel. So in actual fact we've got exactly the same thing, so the resistance will be the same. You can see that cancels, so we've got this divided by that would equal 1. So your answer is actually C. 16C. For question 17, it says a circuit shows a resistor connected in series with a battery and a resistor of 10 ohms. The EMF of the battery is 20 volts with negligible internal resistance. Now, because we got negligible internal resistance, this is the formula dealing with internal resistance, so we probably won't be using that one. We would just need to work with that formula over there. That will be fine. That's our Ohm's law. The current in the circuit is 1 amp. So which of the following is the resistance R? Now for the whole circuit, we can apply Ohm's law, that V is equal to R times I, or as we have there, the total resistance. We could find the total resistance is equal to V over I, and we have here that it's 20 volts and your current is 1, so we've got a total resistance of 20 ohms. So this is 10 ohms, so therefore this also must be 10 ohms, because they are in series. This is our series formula. You just add the resistances, so you add the two together, so this must be the correct answer there for that. Going on to 18, we have three identical resistors are connected to a battery as shown. So we have X, Y, and Z. Which of the following is a correct statement? So we have the current through X is greater than through Z. That's incorrect, because we would have our current, usually we would have our current going this way, and at this point over here, if the current will actually have to split into two branches. So you're going to have a current divided between the two. This one here, I, we call this IX and IY. I or X plus IY would equal I, the total current there. So that's not correct. The potential difference across Z is greater than that across Y. So we have the potential difference across this Z. Now this all depends on the this will all depend on the but it says over here 3 identical resistors. Okay, so that's very important to see. So because V is equal to I times R, and each one of these are identical, and because I is greater than these two, this I going through Z will be greater, so this will be true. Let's have a look at the other ones just to see what they are. The potential difference across resistor X and Y together is the same as that across Z. No, it's not necessarily the same, it all depends, but we do know that the potential difference across X also equals the potential difference across Y, and the current through Z is less than the total current through Y, X and Y. As we've said, that is not correct, so it must be B. B is the correct answer there. Now here we're actually going into our magnetism, so let me just pull these up. Not that we're necessarily going to use this, but this is our fields and forces where we've got magnetism and so forth. We're going to be using these formulas. So current is established in a coil in this direction. The direction of the magnetic field at point P. Now at point P you have the current going past it here. Now you use, to find the magnetic field, you use your right hand, where your thumb is in the direction of the current. So you put your thumb of the right hand in the direction there, and your curled fingers on the direction of the magnetic field. Now if you do that, I think you'll see that your curled fingers would be pointing down. It would be your magnetic field would be coming like that. So you are actually going to be B. It's actually going to go into the plane of the paper. So it will be this one over here. So you've got to remember that rule.